The relatively simple idea that I used to solve this problem. 14 is congruent to 8. And rather than specify the modulus, I'm just going to leave the modulus as a variable. We'll call the modulus m. Okay, so you could think of this as a question all by itself. How many moduli would satisfy this? Well, you know that 14 minus 8 is 6, right? 14 minus 8 equals to 6 is pretty indisputable. But notice that 6 has 3 divisors. Now notice it's also equal to 2 times 3. And so that leads to the truth that we have 1, 2, 3, and 6 that are divisors of 6. So this all implies that m equals to the only possible m's right here would be positive m's, at least would be 1, 2, 3, and 6. Just that number we just list of numbers we just enumerated over there. Three and 6. Okay, folks, so you get the drift here. And that's what we're doing right here. We have an unknown value here, x, and then we're given that there are exactly 4 m that satisfy it. And the m, a member of natural numbers, means positive integers, okay? So we're looking for the largest negative integer that takes care of business here. All right, so let's move along. See, Saturn. Now, the only integers with 4 divisors are in this form. We've just seen 2 times 3 is this form PQ. Right here, 2 times 3. So that kind of composite number always has 4 integers, and you can list them. Just 1, P, Q, and PQ, right? And also P cubed has 4 divisors. You can list them very easily. That would be what? 1 P squared. So you got to look over those guys also. But these are the only forms that have 4 divisors, which is kind of interesting, and it makes the prime factorization that much more important, as you can categorize the nature of the divisors. And so these are the only 2 forms, namely P cubed and P times Q, where P and Q are prime, okay, that admit 4 divisors. So the largest negative integer is -1, okay? So we'll start there. And you can see right off that you can't check this box because when you subtract 231 and -1, you get 232, which has this prime factorization, which is not one of these forms, okay? Not one of these forms. So that doesn't work, okay? And then when you get to -2, which is the next largest negative integer, 233 is actually prime. So it's not in the form either, right? Let me write prime right above it. 233 is prime. You can verify that. It takes a little bit of time. Just check all the divisors between or less than the square root of 233. All right. And right here, again, this is not in the appropriate form right here. Okay. So yeah, you guessed it. Now I'm actually going to have to write something down. Let's try it out for 233 or 231 congruent to -4, which is our next. Okay, like that. Okay, now what you see right here is you get 235. Right, when you take that difference. But 235, you guessed it, is in our form. It's equal to 5 times 47. 5 times 47, and both of those are prime numbers, right? And so the 2 m's, the m's that we were looking for earlier would be 1, 5, 47, and of course the number itself, 235. And y'all, if you want to think about this more theoretically, even it's divisibility. Integer division is transitive. If A divides B and then B divides C, A divides C, right? It's based on the transitivity division property of the integers, and that actually creates a partial order, believe it or not. I think, what is it, reflexivity is not satisfied, or something's not satisfied. But anyway, one of the three things about equivalence relations isn't satisfying. But anyway, that's it, folks. The answer to the question is x equals to -4. It's the answer. And I think Saturn probably is excited about that. But Saturn's always excited, it appears.